Excuse me. Hi, everybody. Today is Monday, April 1st. Is it today you tell a lot of jokes? Okay, so this is our exam too. The highest score is 88, lowest score is 22, and average is 63.125. So we have no A and 2B, 2C, 1D, and 3 half. So if you didn't do well on this exam, don't forget, we can use the final exam score to replace one lowest chapter exam score. But I wish if you didn't do well, if your score is less than 70, please see me every week, okay? Because I want you to make sure you understand every problem in the class notes, in your homework, and in the practice exam. So yeah, because all of you agree, let's change our class policy. We raise the homework percentage from 10 to 20 and decrease the exam percentage from 80 to 70. Okay. All right. So this week, Wednesday, you have homework 7 on 9.3 and 9.4, and also quiz 4 about 9.3 and 9.4. So last week we finished 9.5 already. So I plan today and Wednesday we will finish 9.6. And on Wednesday we also start 10.1. So please also print out 10.1, okay, for the Wednesday class. Okay. So you can see our schedule. You're gonna be very busy. Every week you either have like one assignment and an exam, or 2 assignments. So don't forget that you can drop the 2 lowest homework assignments and drop the 2 lowest quizzes. But I still hope you can do all the homework because they are helpful for your exam. So, like I said, I hope to see you more often in my office. There's a table outside of my office. Feel free to bring your laptop and then work on your homework there. When you have questions, you can just come inside and ask me. Okay. Yes, this is your hardest math class. And yes, it's the most challenging one in your college, right? So let's put more math first, and I'm always there to help you. Okay, so double integral. Okay, so what is single integral? What is double integral? So in Cal 1, we talk about integration. So we have y is a function of x, and then this is a curve on the xy plane. And then what's the integral? The integral, like from a to b of f of x dx, this represents the area under the curve from a to b. Right, everybody? This is from Cal 1. Now, Cal 2. What is double integral? Well, you have z is a function of x and y. Then you know what it is. You know this is like a surface. Do you agree, everybody? It's like a surface. And then you have your domain. For example, on the one dimension, your interval is from A to B, right? Your domain is from A to B. Or not the domain, the restricted interval is from A to B. But now, in surface, in R3, then you need to have a region. For example, we have a region on the xy plane. So this is the region. And then you look at, what does this region look like? Okay, maybe like that. Then the double integral of f of xy, and you have dx dy, and let's say down there, this region is D. On this D, this represents the volume. Okay? The volume under the surface. Is that okay, everybody? Yes. So in Cal 1, the single integral represents the area under the curve. Now, in Calc 2, the double integral represents the volume under the surface. Okay, this is what it means. Then, when we compute the double integral, we will integrate twice from the inside out, one variable at a time. So here we have two double integrals. Do you see the surface? They are the same surface. The inner function are the same, right? But look at the order. The first integral, it means we always evaluate from the inside to the outside. So we first, you see is dy. So the first thing we integrate with respect to y first. And then after we integrate with respect to y, we will get a function of x. Then we integrate with respect to x. Okay, everybody? So let's do that. Okay, so copy the outer integral, and we want to integrate the inside with respect to y. What's the integral of 10 with respect to y? Not derivative, integral. Yes, 10y. And then how about a minus 3x squared?
It's 0, right? Because it's constant.
Derivative is 0. The integral is... Yes. Right, I know the last 3 sections were all about derivative, partial derivative, but no, antiderivative, integral. So your power increased by 1. Okay, next. Y to the 4th over 4th. Yes, very good. And now the y evaluate from -1 to 1. So these are the y bounds. Okay, y goes from -1 to 1. So far, so good, everybody? And we still have the dx. So the outer integral, just copy it. We're integrating the inner integral with respect to y. So far, so good, everybody? Keep going. So copy down. Now, you're going to plug in the y equals 1. Subtract, you plug in y equals -1. Right? We plug in y equals 1. What happened? 10 times 1, yeah, minus 3x squared times 1, right? And minus 1 over 4. Because 1 to the 4th is still 1. Right? We plug in y equals 1. Subtract, we plug in y equals -1. What happened? 10. Yeah, -10. And then also positive 3x squared. And then, what's -1 to the 4th? +1. Okay. So this is actually negative. Because -1 to the 4th is 1. So you still have -1 over 4 dx. Okay. Let's simplify that. This is 10 minus 3x squared minus 1 over 4. And then when you distribute, what happens? 10, and then minus 3x squared, and then, yes. 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 And, okay, let's see, what's the attendance sheets? Here we go. Thank you. Okay, so let's combine the like terms. What's the constant term? 20 and minus 3x squared. That's it, right, everybody? Oh, yes. Sorry, my bad. Yes. So you see now the inner, after we plug in the y value, we get a function of x. Right? Ooh. We can integrate now. So integrate with respect to x. So you can see this is function of x after you plug in the y values. Now you can integrate with respect to x, which is, what's the integral of 20? What is that? 20x. And what's the integral of 6x squared? By the way, the exam solutions are posted on the website. Because we're very behind schedule, we don't have time to go over each problem on the exam solution. But I hope you can check your answers and write down the correction next to it. And then you can ask me questions, and you can fill out the exam wrapper and the exam correction on Canvas. Okay, so what did you say? What's the integral of 6x squared?
6x cubed.
Yeah, very good. And we evaluate from -2 to 1. Exactly. Change this to 2. Good. Now we plug in x as 1. What happened when we plug in x as 1? 20, and then minus 2. Yes, everybody? Subtract when we plug in x as -2. What is 20 times -2? -40. And then -2 cubed. -8 times -2 plus 16. Good. Okay. What is 20 minus 2? 18. What is -40 plus 16? -24. But minus negative become plus 24, which is 42. The answer is 42. Is that okay, everybody? So how do you integrate a double integral? From the inside out. Okay? Look at your inside. Oh, dy. So you integrate with respect to y first. And after you integrate with respect to y, plug in the y balance. And after you do the cancellation, simplify, you get the inner is now a function of x. Then you can integrate it and then plug in the x balance. Is that clear, everybody? Okay, so this is one example. And for the second part, can I show you the note with answer? Okay, so yeah, I want to spend more time to do the harder problem. So the second part here, you can copy down the notes after you get home. Okay, so now we can just focus on the theory. Okay, the second part. You see the inner part is dx, so we integrate with respect to x. So tan integrate with respect to x is tan x, right? And -3x squared becomes x cubed. Yes? And then -y cubed is now -y cubed x. So So this is the integral with respect to x. Now we plug in the bound, -2 to 1. We plug in 1 first, so we get 10 minus 1 minus y cubed. Is that okay, everybody? We integrate, and then we plug in 1, and subtract, we plug in -2. So we get -20. -2 cubed is -8. But because there is a negative in front of it, it becomes +8. And then plug in -2. -2 becomes +2y cubed. Is that okay, everybody? Yes. And we combine them. 10 minus what? 10 plus 20. Oh, okay, sorry. This is 9. And then minus y cubed. And here, -20 plus 8 is -12. The plus negative become +12. And negative plus become -2y cubed. And then we combine the 9 and 12 together is 21. We combine the -y cubed and -2 cubed, it becomes -3 cubed. Is that okay, everybody? And then when you integrate with respect to y, you get 21y minus 3 times y to the 4th over 4. Right? So far, so good. We plug in -1 and 1. So plug in 1, we get 21 times 1 minus 3 over 4. 1 to the 4th is 1. Minus, we plug in -1. When we plug in -1, it's -21 and minus 3 over 4. -1 to the 4th is 1. Therefore, we get the 3/4 and 3/4 cancel. And 21 minus negative become plus. 21 is 42. Do you see they're the same answer? So in this case, you can actually draw the picture. Like, what is the region on the xy plane that you want to integrate? Like, for example, what do I mean? In Cal 1, you have the area on the interval AB. And then in Cal 2, the double integral, you are integrating on the region in R2, right? The region is really the D. And you can see, what is the region here? This is the x values. This is the y values. So if you draw the picture on the xy plane, can you see the x value is from -2 to 1? So -2 to 1. And then can you see the y values is from -1 to 1? This is the rectangle. So the region, okay, the region on the xy plane is a rectangle. So you have a surface and your region is a rectangle. This double integral represents the volume under the surface on this rectangle. Is that clear, everybody? And because the region is a rectangle, the order where you integrate does not matter. You can integrate the x first, then the y, or you can integrate the y first and then the x. Okay. And how about the picture? What does the picture mean? Okay. So if you have the order dy dx, what do? Is you look at the outer one. The outer one is dx. So you have your x-axis and your y-axis. With dx is you draw a little change of x. And you imagine, everybody look at me, this is important. We try to understand what it means. So dx is a little width. And then you can draw a little rectangle here on the region. And then you have the inner parts. So you look at the total, right? The outer is dx. Then you draw a little width. And then the inner part is gonna be you get a curve. So you have this, and then you cut it, you get a slice. Okay? And this cross-section area is actually the integral of the surface with respect to y. Can you see this picture? Mm-hmm. And then when you integrate double integral, becomes you add all the slices together. Then you get the solid. And if we use the order dx dy, you look at the outer one. The outer one is dy, so that means your little width is on the y-axis. And then you draw the rectangle. Do you see you get a slice there? And then the cross-section area is going to be the inner part. It's the integral with respect to x. And after you integrate this with respect to x and plug in the x values, you get a function of y. Yes, you get a function of y. And this is the cross-section area. And when you sum all the slices together, you get the volume of the solid. Okay? So the order, it's just the fact that how do you cut it? Do you want to cut it perpendicular to the x-axis, or do you want to cut it perpendicular to the y-axis? Is that clear? Mm-hmm. Yes. Good. Okay. So this is what it means. Now let's see. Alternative way of thinking the double integral. So that's why we often write this double integral is the surface. We integrate on the region on the xy plane and dA. So we call dA is the area differential. It could be dy dx or it could be dx dy. So this is the area differential. And when the base region R, so this region R, when it is a rectangle, then the order in which we integrate does not matter. Okay? So rectangle means your bands, they're both constants. Okay, so you have your y band, x bands, they are all constants. Then you get a rectangle. If your region is a rectangle, the order does not matter. You can like here, you can simply switch the order, you get the same answer. Okay, but what happens if the base region is not a rectangle? This is the hard part. Okay, and let's do that. Okay, let's see. When the base region is not a rectangle, we're gonna draw a picture. So example, let R be the triangle in the xy plane bounded by 0. So x is 0. Let's draw the picture, okay? So we have x equal to 0. You know, x equal to 0 is the y-axis. Y equal to 0 is the x-axis. Yes, everybody? And then x plus 2, y equals to 2. All the power 1, you know, this is a line, right? And how do you draw a line? How many points can fix a line? 2 points fix a line, right, everybody? So you can find the intercept. Like you can let x is 0, and then you get 2y equals 2. What is y? 1. So we are at the point 0, 1. We can also let y to be 0. Then what is x? If you let y is 0, what is x? 2. Oh, yes. So the point is 2, 0. Therefore, 0, 1, and 2, 0. Those are the 2 points. And you connect them. So R is the region. Bounded by x equals to 0 is the y-axis. y equals to 0 is the x-axis. And this line. This is the region. So far, so good, everybody? Part A. Set up the bounds for an integral. So we don't know what the function is, but we know this is the region. We want to set up the integral with the order dy dx and the order dx dy. Okay? This is what we are doing. And let's draw a picture. Okay, so put a line there. You know we're gonna draw two set of picture. Okay, let's draw that picture again. So this is 0, this is 1, and that's the 2. So draw again. Let me do it better. Okay. So this is the region R. When you see the order dy dx, then you look at the outer one is the dx. So when you see the outer one is dx, then you draw a width, the width dx on the x-axis. So like here, draw a little width dx. We know this is like 1. Draw a little width dx. So look at the outer one. It is dx, draw a little width on the x-axis. Okay? Then what do? Is, you know, this little width, cut this region in a little rectangle. So can you see this little rectangle? That's the dx, that's the little width dx, and you can draw the rectangle. And now you can see here and here. You can express y is a function of x. Okay. Do you still remember before we talk about how to find the volume of a solid of a solution? Okay. The volume of solid of a solution, you kind of also draw a little rectangle there, and then you want to imagine what happens when you rotate about the x-axis. You have your big R and you have small r. So this is similar to that. When you see dx outside, you draw a little width, and that gives you a rectangle on this region. And now y is a function of x. So how do you set up the integral? Leave some space there. You know, we have the surface f of xy. And now because the order is dy dx, x is always between two numbers. Okay? The outer one, the x, is between two numbers. And then the inner one, the y, is now function of x. Okay, look at the bottom part. Can you imagine when your little rectangle is moving? Look at the bottom part. It just stays here all the time. Do you agree? So the bottom part, you want to express y is a function of x. And the bottom part corresponds to y equals to 0. Yes, everybody? When your little rectangle is moving, the x-axis is y equals to 0. That's the bottom part. Look at your top part. Your top part is on the line, right? But you want to express y. It's a function of x. So how do you do? X plus 2y equals to 2. You want to solve for y. What do you do? How do you solve for y? Subtract x. You get 2y equals 2 minus x divided by 2. Then we get what? 2 over 2 is 1 minus 1/2 x. Yes, everybody? You see y bounds. They are 0, and y is the 1 minus 1/2 x. Okay. Y is a function of x. That's the y bounds. And our x bounds is between two numbers. What's your x? When you move within this region, what's your x? From where to where? X. The x is from 0 to 2. Exactly. So the x band is from 0 to 2. So far, so good. So when we set up the integral, do we look at the surface? Do we look at the surface at all? No. All these, just look at the region on the xy plane. Okay, everybody? And look at the order. Who's the outer one? Outer one, dx. You know dx is the change of x. That's why you draw a little width on the x-axis. And what happened to those little widths? You get a rectangle, right? And then your x is between two numbers from 0 to 2. And your little rectangle is like moving, right? Because what it means, so this is the xy plane. And you have a surface on top of it. And then you get a lot of slides, right? On top of each rectangle, your cross-section area like that. When you integrate all together, you get the volume under the surface. So everybody okay with the setup? Mm-hmm. Okay, now let's do the other side. So draw the picture again. Yes. Do you like drawing pictures?
That's all we have to do. Right?
Yeah. So we draw the picture. And now, because the outer one is dy, what do you do? Yeah, draw a little wave on the y-axis. The little wave dy here. Ooh, what happened? You get a horizontal rectangle dy. Everybody? Okay. Now when we set up the integral, the inner function, we don't care. It could be anything, right? But then here, the order is dx, dy. You see y is between two number. Can I just use this notation for number? Yeah. Y is between two number. And then what happened to x? X is a function of, yeah. So x is function of y. Look at your x. It is a function of y now. Can you imagine now your rectangle is not moving up and down? Can you imagine? Your little rectangle is moving up and down. Okay, who is the smallest number? By the way, when you talk about the x, smallest number is more to the left. The bigger number is to the right. So the smallest x is this point. Can you see when you move it, it just always stay here? What do you say this? X equals the vertical line, x equals 0, right? The vertical line, x equals 0. Yes, that is the y-axis. This is the smallest x. How about the biggest? Do you see the biggest is on the line? And you want to solve for y or x? You want to express x in terms of y. So you want to solve for x. How do you solve for x? Yes. See? Now our x bands is from 0 to 2 minus 2y. Small is x and the big is x. And y is between one number and one number. Look at your y. 0 to 1. Yes, our y band is from 0 to 1. Okay, so this is when our region is not a rectangle. Do you see if the region is not rectangle, you cannot simply just switch them. They're not the same. You see this function? It's not the same. So you cannot just switch the order of integration. It really, the function will change. So you actually need to draw the picture and figure that out. Okay. So caution. The bounds on the outer integral should always be constant, no variable. Look at this, the outer one, if it's dx, then x is between two numbers. If the outer one is dy, then y is between two numbers. So the outer integral, okay, the bound on the outer integral should always be constant. Or if all the four bounds of the integral are constant, then the region must be a rectangle. In this case, the order does not matter. Okay. So far, so good, everybody? Okay, part B. Once again, let R be the triangle in the xy plane and bounded by the previous picture. Now evaluate the double integral in the case when the f is 1. And how does this value related to R? Okay, so we have the simplest case, the f is just 1. Okay, so let's do that. Okay, so let me put a line here. Okay, the first integral, you have 0 to 2, and then what? 0 to 1 minus 1 half x, and the f is 1, and dy dx. Okay, that's the first one. The second one, let me also copy that. So 0 to 1, 0 to 2 minus 2y, and the f is 1, dx dy. So far, so good? Okay, let's integrate them. Okay, how about you tell me the answer one by one? Patrick.
Hi.
So we integrate with respect to what? Yes. What's the integral of 1 with respect to y? 1y, yes. And we evaluate from 0 to 1 minus 1 half x dx. Oh, yes. See? I popped in the wrong numbers too. So we have to check our work carefully. Yes. Okay. So, yes, 0 to 2. And then we plug in the upper values, right? 1 minus 1 half x. Yes, everybody? And minus, you plug in y is 0. Yes, everybody? Okay, good. And minus 0 is gone. We don't need to look at it. Now, did I make a mistake again? I copied. It should be dx. Yes. So when you work on this problem, you really need to be patient because you have x and y and a lot of numbers, and so every step check your work. Okay. I would say you probably can feel that our problems getting harder and harder. Like each problem is long. So if your setup is raw, then everything after is gonna be all raw. So I would recommend you after you set up the problem, check your setup multiple times before you continue. Otherwise, you just spend a lot of time working on the wrong problem. And usually, the problem, if you didn't make a mistake, you're able to calculate it and get the answer. But sometimes if you make a mistake, your number might get very complicated, or you might get integral that you're not able to integrate. So in that case, yeah, go back and see and check your setup if that is correct. Okay, now integral with respect to x. Bethany was integral of 1 x. And then the next we get that was the integral of 1/2 x. X squared over 4. Yes, good job. We evaluate from 0 to 2. Yes, everybody? We plug in 2. Oh, x is 2 minus, what is 2 squared? 2 squared, 4 over 4 minus, what happened when you plug in 0? 0. Ooh, what is your answer? Exactly. So the answer is 1. Okay. Can you do the right part? Integrate with respect to x. Okay. So integral of 1 with respect to x is x. And then you plug in the 2 minus 2y and plug in the 0, right? You get 2y minus y squared. Yes, everybody? Evaluate from 0 to 1. So 2 times 1 minus 1 squared minus 0. Do you also get 1? Yep. Yeah, that's right. Yes. It's the 2.
Oh,
And
yeah,
then y
okay.
squared over 2.
Yeah, yeah.
Yeah, and then we have the 2. Right. You're welcome.
Where did the 1 go?
Where did the 1? Where?
Yeah, the 1 dx dy, all the way up. All the way up.
Here?
Yeah.
Oh, integral is back to x. The integral.
Oh, it's a
1.
line. Okay,
Yeah,
not a
yeah.
1.
Right. Because it's the power. That's a 1.
Okay.
Yeah, the one. Antiderivative. You increase the power
Okay.
of the variable.
So close
Because
to-
this is like linear, a constant become linear term.
Yeah.
Because if this power is 0 and then increase one power become power 1.
Okay.
So integral of 5 is then 5x. Integral of 10 is 10x. Right. Okay. So how does this value related to r? Okay, what does this mean? Okay, so let's draw a picture. You have the x-axis and the y-axis and the z-axis. This region. Okay, look at this region. Do I have the picture before? Okay, up there. Do you see the x's from 1 to 2? Sorry, 0 to 2, and the y is from 0 to 1? Okay, so x is from 0 to 2, and y is from 0 to 1. This is a triangle on the xy plane. And then here it sets f equals to 1. F equals to 1 is what? Horizontal plane, right, everybody? You have horizontal plane, but you restrict on this region. Do you see? You get some cylinder like this. Like the base of a cylinder is a triangle. Can you imagine, everybody? Cylinder. Oh yeah. So this is a circular cylinder, but any cylinder is like the base, the top, and the bottom are the same.
Oh, okay.
And then
Okay.
yes. But usually when we say cylinder, we just mean circular cylinder.
Yeah, that's what I was thinking. Circular cylinder.
Yeah, but cylinder can be generalized. Your base could be anything. It could be a triangle. It could be.
Cylinder.
Yeah, it's a cylinder. Right. Yes. Okay. So now, the double integral means find the volume of it. And you know volume of a cylinder is area of base times height. Everybody okay with that? And here, area of base, because base is a triangle, right? And remember, for triangle, your area equals 1/2 base times height. So that's why it's 1/2, and here base is 2, height is 1, right? So 1/2 times 2 times 1. And multiply by, what is the height of this cylinder? 1. Exactly. What do you get? 2 and 2 cancel. You get 1. So we actually can find the answer by just drawing the picture. And it matches with our double integral. Okay? So do you have a better idea what the double integral means? This is when the f is a constant, then you get a horizontal plane, right? And in general, f can be any surface. That's why, area of region by double integral. So if you have the inner part is just 1, then the double integral, it just represents the area of the base. Because your height is 1. Then the volume of the cylinder is just the area of the base. Is that okay, everybody? So average value of a function over a plane region is the following. The double integral is the what? Is the volume, and then you divide it by the area of the region. And this match with our average value. Do you still remember average value of integral from a function from a to b? That is 1 over b minus a, and then the integral from a to b f of x dx. Do you remember that? It's like the area over the length of the interval. And here we just generalize. So the average value of the surface is now the double integral and over your base region area. So it kind of matched with our definition for average value when we have a function of one variable. Okay, good. So let's continue next time. So next time also print out 10.1. Okay, have a nice day. Work on your homework, exam correction and wrapper. And yeah, I will be always in my office. Come to ask me questions. Bye.